Okay. Coming to the first. Yes. Now, this is a basic exam. How many carbon atoms are there in this? See, there are 4 carbon atoms, right? There are 4 carbon atoms. We have written the root word, right? But. And how about the primary suffix? Whether to go with "ein," "een" or "ein." What do you see? Whether you see single bonds between carbon atoms or double bonds or triple bonds. See single bonds, it is considered to be saturated, right? So in case of saturated ones, the primary suffix is "ein." That's it. So this is the name of your compound. Is this okay? Now look at this. See, I can go this way, right? I'll get 5 carbon atoms. Even I can go this way also, right? Isn't it? Even then I'll get 5 carbon atoms. Starting from this, I can go right up to this. How many carbon atoms do I get? 5. The same number of carbon atoms is what I'm getting, right? How to take? Of course, both are same, right? You can go either this way or this way. It doesn't make any difference because you are getting the same number of carbon atoms. I mean the same 5 carbon atoms. But my point is, if suppose you go this way, then the numbering will be from which end? Whether to give numbers from this end or from this end. You know, remember when you take or when you give numbers from a particular end, see that the side chain, like suppose if you consider this is a side chain. Then the side chain containing carbon, I mean the carbon to which the side chain is connected should get the least possible number. So if I give numbers from this end, then this carbon to which the side chain is attached gets the second number. I can also give numbers from the other side. But see, the carbon atom to which this group is attached is getting the least number 2 when numbering is given from this end. But from the other end, it is getting a number 4. Remember, it should get the least number. So this numbering is correct, whereas this numbering is wrong. Let us just forget about this numbering because it is anyway wrong and we are getting a big number to the carbon to which a side chain is attached. So I've just taken this one into consideration. Now, what is this group called? The one that is connected to the second carbon. How many carbon atoms are there in this? Root word is again myth. Here you got 3 hydrogens and a bond. This is what I was telling. Now, what do you have here? Is it the same CH4 or something else? I mean, 1 hydrogen less than that of methane, right? Alkane, of course, methane is an alkane. Alk is meth, ane, of course, as it is written. But here, when you compare this and this one has one hydrogen less than this one. Alkane minus one hydrogen is alkyl. In primary suffix itself, I told you. So let me call this methyl. At the second carbon, there is a methyl group. So let me now write the name of this as 2-methyl, because second carbon has methyl group. 2-methyl. Now go to this. Because we are done with this area, let us now move on to the parent chain or the principal chain. What is that? How many carbon atoms are there in the parent chain? Root word for 5 carbon atoms. Pent. Then can you see single bonds or double bonds or triple bonds between carbon atoms of the parent chain only? Only single bonds. So we can call it pentane. Look at what we have written. See, this is anyway the root word, right? Now this is the primary suffix. Of course, we don't have any secondary suffix. It's missing. No secondary suffix. And you know, even the primary prefix is also missing. There is no primary prefix. Because it is not a cyclic compound, we cannot write the primary prefix cyclo. Here it is missing. Now what is that we have written here? It is the secondary prefix. Remember, methyl group is always a substituent type. It will always be there only at the secondary prefix area. I told you that there are certain things which are always substituents, but there are certain functional group which, of course, are treated as substituents when there are groups with more priority than them. So now in this, what are the things that we have? We have secondary prefix, point number 1. We have root word and we have primary suffix. Is that okay? If suppose we go this way, we get only 5 carbons, right? Suppose we go this way, how many do we get? Only 6 are there. Even if we go from here to here also, you get the same number of carbon atoms, right? You cannot. It has to be a continuous one. You cannot split it. You cannot just go in a discontinuous manner. I think now you got the idea that the first thing is to select the longest continuous. Now let me select this way. See how many I'm going to get. And it is a continuous one. How many carbons are there in this? No, there are 7. Now the next thing is to give numbers. You can give numbers either from this end or, okay, from this end, let us give numbers. 1, 2, 3, 4, 5, 6, 7. From this end, there is something at the 3rd carbon and there is something at the 5th carbon, right? Now, it can also be given numbers from this end. Let us check. So this is how you can give numbers. Even now also, there is something at the 3rd carbon. There is something at the 5th carbon, right? 3 plus 5 is what I call sum of locands. Go with any of these. So let me just clear up the pink ones. I don't want to go with this. Let me. So now, let me first write it has. See, we have, you know the name of this. This is called methyl, right? So methyl. Just now I told you how we got this name methyl. Methane minus hydrogen is methyl, right? Methane is CH4. When a hydrogen is subtracted, we get CH3. This is methyl. So methane minus hydrogen. Now, third carbon has a methyl group. Even fifth carbon also has a methyl group. So in such a case, we have to call it 3, 5 dimethyl. Is this okay? Because the same methyl group is present at two positions. I mean, attached to third carbon as well as fifth carbon. We can simply say that it is, of course, 3-methyl, 5-methyl, nothing but 3,5 dimethyl. Di, 2, methyl, 2 methyl groups. Where are they located? At the third carbon and at the fifth carbon. Now come to the parent chain, this one. How many carbons are there? What is the root word for 7 carbons? Hept. Hept. And because single bonds are there between carbon atoms, let me write ane. Is everything okay? Hept is the root word. Ane is the primary suffix. And this 3,5-dimethyl is the secondary prefix. No primary prefix and no secondary suffix. This is what, of course, is possible, but it has only 5 carbon atoms. Let's see if we can get more carbon atoms in our parent chain. So for that sake, what I've done was, like, I've taken this way. I mean, this is what I wanted to take. If you see the points of connection, so this is one point of connection and this is another point of connection. So
yes, sir.
This is nothing but 7 carbon atoms with the 2 side chains, or you can say 2 substituents. Let me just clear this off. Let me just check whether I can get more. I think rather than going, even this is also something with the same number of carbon atoms. You got 7 carbon atoms here. Even if this is treated as the parent chain, you'll get 7 carbon atoms, but only thing is only one connection. This is the only connection that you have to the parent chain. So it is 7 carbon atoms with only one side chain or one substituent. Earlier one had 7 with 2 side chains. Now, shall I go this way? How about this? See, this one has the same 7 carbon atoms, but see the points of connection 1, 2, and 3. Of course, rather than going this way, even this way is also okay. Not a big issue. You can either go this way or this way. Both are same. This is the parent chain. The earlier ones are not the parent chains. If this is a parent chain, it has a 7 carbon atoms and of course 3 side chains are 3 substituents. The earlier ones had 7 with one side chain, 7 with a 2 side chains. So we need to be logical. The one with more number of side chains is selected as the parent chain, remember. More number of side chains. Next. Okay, let us take one more. See, even this can be numbered in two ways. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. You got 9 carbons. Of course, two side chains. You know, this has 2 carbons. When there are 2 carbons, the root word is ether. And when you have this kind of a connection, I told you that you have to call it aisle. So, at fourth, you got ether aisle. And at sixth, you got myth because there is only 1 carbon. Myth and aisle. Let us just write the numbers from the other end because this time we have written it from this end. Let's see. Let me just strike off these numbers for clarity's sake. I've already written the summary of this one. Now, if suppose numbering is done from the other end, yes, you can. Right. In this case also, you got the same number of carbon atoms, 9 carbons. With the 2 side chains. Again at 4th and 6th only, but interestingly, you know, at 4th you got methyl. And at 6th, you know, you got ethyl. Same. Look at these two things. Forget about the first two because both are same. 9 carbons, 2 side chains. The interesting part is 4th and 6th. 4th and 6th have got different substituents. Okay, let us just check the thing present at the 4th position. The least locant, the least number. You know, it has ethyl, wherein the alphabetical order, I mean, alphabet is E, and here the 4th one has methyl. So that is where you got some competition. When you take things from this end, 4th had ethyl, and from this end, 4th had methyl. So there is a competition between ethyl and methyl. In such a case, follow alphabetical order of priority. 4th ethyl, 4th methyl. This is where you got competition. Competition at 4th position. See, that too competition is between two different substituents of the same family. Ethyl and methyl, both are simple alkyl groups. Competition at 4th position between substituents of the same family. In such a case, you have to follow alphabetical order of priority. Which one comes first, whether it is E or M? Alphabetical order of priority is what you have to follow. So let me follow it this way. E comes first. So this is correct and this is wrong. I mean, numbering from this end is correct. So let us finalize the things from this end. The blue one is correct. This numbering is proper. So first thing is go for maximum number of carbon atoms. Second thing is, if suppose you got two different chains with the same number of carbon atoms, two or more can be possible with the same number of carbon atoms. In such a case, go for something with more number of side chains. If the number of side chains is also the same, then go for something with the substituent at the lowest locant, like in the previous case. Now, in this case, there is competition. So, very interesting. I think the parent chain is this, the straight one, because it has 6 carbon atoms. Nowhere you get 6. No, I think you are getting it. Even this way also you are getting the same 6. But when you take this is one point of connectivity and this is another point of connectivity. So there are 2 points of connectivity when you consider this. But when you consider this as a parent chain, point of connectivity, yes. There are 3 points of connectivity. So let me go with this. Come on. And see, from where do you give numbers? From this end, if suppose numbering is done, it will be like 1, 2, 3, 4, 5, 6. You got something at the second carbon, third carbon, and fourth carbon. Then in such a case, the sum of locants is going to be 2 plus 3 plus 4.
Yes,
it's
sir.
9. Now, if suppose numbers are given from the other end, come on. If it is from the other end, 1, 2, 3, 4, 5, 6. See, from this end it is 3 plus, you got something at third, something at fourth, something at fifth. 3 plus 4 plus 5, 7 plus 5, nothing but 12. Here, in such cases, you have to see that the sum of locants is least possible. Sum of locants is least when numbering is done from this end. So let me go with this. This is wrong. So let us forget about this numbering. Let's see. But see, there is no competition also. From this end, you got something at the second itself. From the other end, you got something at the third. So no need to even check what is there at the second and what is there at the third. If both are at second, we would have checked. Like in the previous case, if the second one has ethyl from one end and the second one has methyl from the other end, then we would have checked it properly. But Even that kind of a competition is not there in this. So let me just forget about this straight away. Forget about this. So the numbering to be considered is this 1, 2, 3, 4, 5, 6. So the name of this can be written as, look at this. You know, at the second thing, you got a methyl group. Even at the fourth one also, you got a methyl group. Both second and fourth have got methyl groups. Now at the third position, you got 2 carbons. Means it, the root word. And when this kind of connectivity is there, say aisle. I told you, it aisle. This one is, you know, 1 carbon. It has just 1 carbon. Mith and the point of connectivity. Then say aisle. Mith plus aisle is methyl. Now we can write the name. Even while writing the name also, we have to follow alphabetical order. So let me first write 3-ethyl because he comes first. 3-ethyl 2, 4 dimethyl. Look at the way I'm writing. At the third carbon, we have ethyl group connected. At the second and fourth, we got 2 methyl groups connected. And finally, coming to the parent, see, overall, right up to this, it is the secondary prefix. Now, coming to the parent has 6 carbons. Parent chain has 6 carbons with the single bonds between them. So it's very clear. You don't have, of course, primary prefix because it is acyclic, not a cyclic one. Then look at this. This is the root word. And coming to this, it is the primary suffix. No secondary suffix. It's very clear that even if we go this way, I mean, here we are getting 6 carbons with the third carbon having a methyl group and the same third carbon having a propyl group. 3 carbons prop and the point of connectivity. So yl, prop yl. 3 carbons, sorry, 6 carbons with a methyl group at the third carbon and also a propyl group at the third carbon. Even this way also it is okay, not an issue. You are getting the same number of carbon atoms, 6, with the third carbon having a methyl group and also a propyl group. And of course, a double bond after first carbon every time. So let us just go with this. Come on. Let me just give numbers. Remember, double bond is very important. So no question of checking it from either side's thing. No, we don't check. 1, 2. This is the third one, fourth one, fifth one, sixth one. See, you got this at the third carbon and this overall thing at the third carbon. Let us first write them up. See, this is methyl. Meth because 1 carbon is there and this connectivity gives yl. And look at this. This is prop yl. Prop because 3 carbons. Yl because of this connectivity. Let me write that. I know that M comes first in alphabetical order. See, while writing the name, we have to be very careful. Come on. 3-methyl. Then 3-propyl. We're done with that. You know, even when you write the name, you have to be very careful. Hyphens before and after the number. commas only between the numbers. But of course, here we did not get any two things to write a comma. So two numbers to write a comma. 3-methyl, 3-propyl, I think is clear. Now, my secondary prefix is ready. This is the secondary prefix. No primary prefix because it is not a cyclic one. Let me straight away go for the root word. Yes, it has 6 carbon atoms. The root word is hex. Interesting. Coming to the primary suffix, now the very interesting one. You got a double bond after first carbon. So that is been indicated here. This is how you have to represent the position of a double bond. It is between first and second. Means after first. Take the lowest number. We are done. So this is the root word. And this is of course the primary suffix because there is a double bond. Forget about single bonds when you got a double bond. Looks to be a kind of mirror image. This and this both are same. So it can be numbered from either sides. Let us check. 1, 2, 3, 4, 5, 6. 6 carbons with 2 methyl groups on the second carbon. And of course, 2 methyl groups even at the 5th carbon. Of course, the double bond after the 3rd carbon. Let us check the same thing from the other end. 1, 2, 3, 4, 5, 6. Same 6 carbons. Double bond after 3rd carbon. Same. 2 methyl groups at the 2nd carbon. 2 methyl groups at the 5th carbon. Everything is same. So we can go with any of these. Let us just go with this. No problem. Even the previous one was okay. Now, how to write the name of this? Come on, let us first write 2, 2, 5, 5. We got 4 methyl groups, 2 at the 2nd, 2 at the 5th. So that is why I've written 2255. 2255, because we got 4 methyl groups, it has to be 2255 tetramethyl. That's interesting. 4 methyl groups. That is what tetramethyl refers to. But where are they located? At the 2nd. I mean, you got 2 at the 2nd, 2 at the 5th. 2255 tetramethyl. We are done with the secondary prefix part. Now let me go for the root word. Hex. Yes, because the parent has 6 carbons. And I think I can go for 3-ene. Because there is a double bond after 3rd carbon. Without any hesitation. It can be written as this. This is root word. And this, of course, is the primary suffix. No primary prefix, no secondary suffix. Look at this. Obviously, numbering has to be from this end. From this end only. Because otherwise it will be, I mean, from this end you got triple bond after the 2nd carbon. If you start giving numbers from this end, it will be after 3rd carbon. So let me go with this because it is giving me the triple bond at the lowest locand, lowest position, lowest number. I think this is okay. Name of this can be given as pent because it has to be always, like in case of double bonds or triple bonds, it has to be alkene, then alkyne. Because you don't have any side chain or substituent, straight away I've written the root word. Because there is no secondary prefix, there is no primary prefix. Both are missing. It's not cyclic. So primary prefix is missing. It has got no side chain. So even secondary prefix is also missing. Penta. The root word has come into picture straight away. This is a root word. Penta. After a second carbon, you got a triple bond. Now straight away I've written primary suffix. 2-ine. Because the triple bond is after the second carbon. See, in this case, numbering has to be from this. Hope you understand why. Because the triple bond is after the first carbon. It will be after the first carbon if numbers are given from this end. So let me go with that. I think I'm okay. But at the fourth one, I have two side chains. I mean two methyl groups. So let me write 4,4-dimethyl. I am done with the secondary prefixes. 4,4-dimethyl. No primary prefix. Straight away the root word. Root word is pent. Because the parent has 5 carbon atoms. Very clear. And then the triple bond is after first carbon. So pent 1-ine. That's it. This is the primary suffix. No secondary suffix. Now look at this interesting example. See if numbering is done from this end. Let us check both. See, in this case, triple bond after first carbon. Double bond after fourth carbon. Let us just keep it aside. And let us give numbering from this end also to check. 1, 2, 3, 4, then 5. Now when numbers are given from this end, double bond is after first. Triple bond is after fourth. When numbering is done from this end, triple bond is after first, double bond is after fourth. Check this out. Now, where do you have competition? Yes, there is competition between these two. After first. When numbers are same, then we say competition. Triple bond after first if numbers are given from this end. Double bond after first if numbers are given from the other end. Means the double and triple bonds are fighting. Both are at the first position, but from the two different ends of the carbon chain. In such a case, what I say is they have got competition. Now, when there is a competition, I mean, when they occupy the same position, this is what competition is. Competition between double and triple. In such a case, when you have competition, simply double bond is given priority over triple bond. Means double bond should get the least possible number. Let me go with this. So this is right and this is wrong. Because from this end, double bond is after the second carbon. No, after the first carbon. Whereas from the other end, double bond is after fourth carbon. So I go with this. And when you, so that is the first important thing. And it should always be written as alk in ein. It has to be spelt in, in kind of. In. I have removed a terminal E because this is sounding as I, which is a vowel. So that's an important point. I have removed E because this is sounding as I. Alk in I. So what is alk here? Alk is nothing but root word. You know there are 5 carbons. So pent. In means double bond. Where is that double bond located? Consider this. Forget about the pink one. Double bond is after first carbon. So let me write one in. Pent one in. And of course the triple bond is after fourth carbon. So it's 4-ine. Pent one in 4-ine. Pent because 5 carbons are there. This is a root word. Because you got double and triple bonds both, this of course is considered to be the primary suffix put together. Double bond is after first carbon. Consider this numbering. Triple bond is after fourth carbon.
Yeah, sir.
So this is very, very, very interesting. This is when you have competition between double and triple bonds. Means when they occupy same position in relation to the two ends of the carbon chain. Let me just give you one more. Check this out. I've got 2 interesting things to discuss here. Now this is of course a carbon. First carbon here, second carbon here, third carbon here, fourth carbon here, fifth, sixth, and seventh. So overall there are 7 carbons. But the interesting point is numbering. Whether to start from this or from this is the point. Let's check. The green one. 1, 2, 3, 4, 5, 6, and 7. You know, here you got 2 double bonds and 1 triple bond. You cannot simply say competition. No, there is no competition thing. When you have more than 2, I mean 1 triple and 1 double, instead of that, here you got 2 double and 1 triple. Let's check. In fact, interesting point is, see, triple bond is after first, it's okay. Double bond is after first from this end. Hope you understand numbering. Let me just give you 1, 2, 3, 4, 5, 6, and then 7. Double bond after first from this end, triple bond after first. This is okay. Triple bond after first from this end, double bond after first from this end. But the interesting point is, if you consider this, you got a double bond. I mean, the extra double bond is after third. But if you consider this, the extra double bond is after fourth. Look at this, after fourth. From this end, it is after third. So even that also gives you an idea of where to give numbering, from where to start giving numbers. 100% it is this. This is wrong. It's not that you are giving a priority to the triple bond.
Yeah,
But
sir.
you are following the least sum. Look at this. 1, After first, you got a triple bond. After third, you got a double bond. After sixth, you got another double bond. Here you got a triple bond. Here you got a double bond. Even here also you got a double bond. So 1 plus 3 plus 6, it is 10. Let's check the sum from the other end. After first, you got a double bond. Even after fourth also, you got a double bond. After sixth, there is a triple bond. After first, after fourth, after sixth. So here the sum is 1 plus 4 plus 6, that is 11. First, let me write the root word. Always it has to be like alk in ein. First the double bond, next the triple bonds. But there is an interesting point here. Of course, the root word is a hept because the parent chain has 7 carbon atoms. Hept. You have to first write the double bonds considering the top one. One double bond is after third, another double bond is after sixth. So let me write 3, 6 di in. Because I have given 2 numbers, I have to say di. But the interesting part is because there are more than one double bonds, extra A has to be added. Instead of simply writing hept, extra A is added. Since it has more than one double bonds. Yes, this extra A is what you have to add. When you got more than one double bonds or more than one triple bonds also. So hepta 3, 6 di in is okay. Let me write 1 in because triple bond is after first carbon. 1 in. So we got everything. Of course, secondary prefix is missing, primary prefix is missing. Straight away we got root word. And this whole thing is the primary suffix. Interesting is this extra A, which is added because there are 2 double bonds. One after the third carbon, another also after sixth one. One after the third, the second one after sixth. Now, this is very interesting. Let us first see the carbons. This is a carbon, this is another carbon, this is another carbon. Interesting, here it is. You got a carbon here and here also. One at this, one at this, one at this. Without any hesitation, I think it is very clear that the numbering has to be from this. Let me tell you why. If suppose numbers are given from this end, it will be after first, after fourth. You got double bond after first and triple bond after fourth. Let's see. Of course, you don't have anything over here. So 100% you cannot give numbers from this end because it will be like 1, 2, 3, 4. After fourth, a triple bond. After seventh, a double bond. 100% we don't go for this. So this one is 100% wrong. We don't just take these numbers also. It cannot be 4 plus 7 when you have 1 plus 4. See, from this end it is after first and after fourth. From the other end it was after fourth and after 7. Here the sum is 5, whereas from the other end it is 11. So the name of this can be given as oct because there are 8 carbon atoms in this. After first, there is a double bond. One in, it's not one in, one in, because double bond is after first carbon. 4 ine because triple bond is after fourth carbon.